Hey everyone! A little while ago, a hot new piece of research was published in one of my field's top tier journals. Researchers have managed to use a specially designed graphene coating to make thermal camouflage, which is a very cool application for graphene in my opinion. The idea behind this invention is to hide or reduce the amount of thermal radiation emitted by objects. Thermal radiation, often referred to as blackbody radiation, comes from all matter in the universe, apart from that dark variety, as a result of absolute temperature. Hot things radiate lots of energy, cold things not so much. The hotter the object, the higher the energy of the radiation produced too. As an example, human body temperature is about 310 Kelvin, and as a result people emit light in the infrared range of the spectrum. Another blackbody source you'll all be familiar with is the Sun. Because the Sun's surface is at a scorching 5800 Kelvin, it emits radiation that we can see. This is exactly the same effect used by incandescent light bulbs, whose filaments can operate up to around 3400 degrees Celsius. Even the most distant regions of space give off radiation due to their temperature. This is called the cosmic microwave background, and corresponds to a chilling temperature of just over 2.7 degrees above absolute zero. How effectively an object can radiate heat is determined by its surface, and is measured by a number called the thermal emissivity. The higher the thermal emissivity, the more radiation an object is able to emit. Rough black surfaces have a very high emissivity, and smooth metallic surfaces have very low emissivity. But let's take a step back now. What does that have to do with graphene making me invisible to the predator? For things like bodies, bad wiring and chihuahuas, thermal imaging cameras measure how bright an object looks in the far infrared. The brighter the image, the hotter the object. What the new graphene coating can do is vary how much radiation is emitted in the spectral range the cameras are looking at. The coating is switched using an electrical signal which changes it from being black to being partially reflective, lowering the amount of radiation given off. This allows the graphene to make itself look the same temperature as its surroundings, and that's pretty cool. Now, I spent a bit of time trying to come up with temperature puns to sign off on, but was told the ones I had weren't absolutely okay. And to be honest, I'd agree, so I won't bother. See you next time. Thanks for watching everyone. If you like what I do, please consider supporting my work via my Patreon page, where you'll have access to a range of in-depth discussions on the physics, chemistry and engineering of nanomaterials. If you'd like regular updates, please subscribe and like the video. It helps so much, and I look forward to talking to you again soon.